classify that as programming. It's still very useful. I mean, it's still a very useful skill to have, is to learn how to write HTML documents, just by hand and not using a tool. So that would still be a very good knowledge to have, a good skill set. But it is not programming by itself. Yep.
Can you double check the audio is working now?
Yeah, I can double check. Yep, it's working.
Okay.
All right. So remember the brain teaser that I gave you guys last week? Someone has done it already. Over the weekend too. But I think it's actually very interesting because let me just go back to that stuff and see whether you guys can correlate that with the stuff that we are talking about now with arrays. Okay? So this is Scratch, and last week we kind of played with it. We have the sprite to walk and bounce back, and I had a little game to catch the mouse. So what we'll do today is to see if there's anything that relates to arrays in Scratch. Okay? So tell me again, what are the things that you can do with an array? What is an array to begin with?
It's a collection of like variables.
It's a collection of like variables. Very good. And how do we get to each individual item in the collection?
We reference it using
an index.
Through an index. What exactly is an index?
2 coordinates, more or less?
Not exactly
Box
coordinate.
1.
It's a sequential number.
It's a sequential number starting with 0. Okay? So you have a collection, which is a box, and then inside the box you have individual items. And each individual item in the box is numbered. Okay? They are numbered from 0, 1, 2, 3, and so on. What are the 2 operations that we can do with arrays now that we know what arrays are? The first one is the vertical bars. What are the vertical bars doing?
The number of elements.
The number of elements. Okay? We can tell how many things are there in an array. What is the other thing that you can do with an array?
You can do
The square brackets.
yes.
And what does it do?
It evaluates numerical
The
expressions.
number of things inside.
No, that's the vertical bar. The square bracket let you access or select one item inside the collection. Yep.
Which one? That's what I was going to say.
Sorry?
Which one? Which item? You said.
Yep. And all you have to do is to make sure that the expression within the square bracket is an integer, and the integer has to be within the correct range. The very last thing that we talked about on Thursday is what if that thing is not, what if the expression gives you a value that is not within the right range? Okay, and depending on the programming language, your program can do different things. In the C programming language, it does the worst. Okay, it would just silently fail, do something that is wrong without letting you know. Okay, the effect of that.
It would overwrite something else, right?
Yep. If you put the array indexing operation as the left-hand side of an assignment statement, yes, it will overwrite something else. And that something else can be just about anything that is important when you execute a program. Okay? The least of your worry is when that is another variable. Okay, that's actually the least of your worry because it can overwrite something far more important than just another variable. In VB, it will just give you an error, a runtime error message with a dialog box that says this program on this line is trying to access an element out of range, and it will just stop the program right there, telling you exactly where the problem is. At least you can start with that line when you debug the program. In Perl, it will just make the array large enough to accommodate that element that you're trying to access, which is good in some case if you intentionally want to do it that way, but it is also very bad if that is not your intent. Okay, so now we are back to Scratch, and try to figure out in Scratch what type of operation in Scratch resembles arrays. Okay, yep, go ahead.
We take one of those yellow things and put a bunch of little things inside it.
Well, not quite. It doesn't have the ability to make arrays, like the way we use arrays in this class. But let's go ahead and make a variable first. Okay, we'll make a variable, and I'll just make the name of the variable A. Okay? and we'll go ahead and do some operations here. All right. And let's see, we'll end the program right away. Now, when you set the value of a variable, you can use numbers, but you can also use a string. Okay, the concept of a string is something like this. You can give it a name, an address, and anything other than a number is considered a string. Basically, it's text information. In other words, I can just spell out something. I can say A, B, C, D, E, and that's fine. Okay, and when I run this program, all it does is to change the value of variable A to A, B, C, D, E. But when you look at the value of A at this point, it is no longer an integer. Okay? What is it now? It is 5 letters. Okay? 5 letters, the first one being A, the second being B, and so on. Each item inside this variable is a character. And there are 5 of them. So does that kind of resemble the concept of an array at this point? It's a container, and inside the container we have like items. In this case, each item is a letter, a character. Is that okay so far? So what we are missing right now is how do we get to each individual one, the square bracket operation, and how do we know the size or the length of this entire variable, the bar concept. All right, so let's go ahead and see if we can do all those things. So first of all, let's see if we can tell how many letters are in A. And I believe that would be operators. Yep. In operators, there's an operation called length of something, and that can give you the number of letters inside, let's say, variable A in this case. So we'll go to looks and just have the sprite to tell us how many letters there are in that particular variable. So we'll go use say sticking here, but instead of hello, we'll just give it the value. We'll go to operators and put length of something in place of hello, and then we'll go to variables and drag A into this portion here. In other words, you can see it actually reads even kind of like English. Say length of variable A. What do you think it should say in this case? Yeah.
5.
5, exactly. So we'll run this program. Oh, it just blinked because I didn't put a delay. We'll go to, let's see, what would be a good way to do it? I can always use for 2 seconds or how many number of seconds. Let's change it to 5. That will give us enough time to read the whole thing. All right. 5. So this corresponds to which operator that we have talked about so far?
The absolute value.
Yep, the bar operation. Okay, what is the length, or what is the number of items inside this array? Is that working out okay? Okay. Yep. Question? Nope. Okay. All right. So the next thing we want to do is to say, well, sometimes maybe I want to access each individual letter inside the variable so that I can examine each letter. Because when you try to play the hangman game, that's what you need to do. Okay, you need to go through the entire word and find out, does it have this letter that you're guessing? Okay, the next one, is that the letter that you're guessing, and so on. So the next operation we want to find is, can we find a single letter out of a multi-letter construct? And we have letter 1 of world here. Okay, so what we'll do is we'll replicate this thing here. So the first thing it will do is to say how many things there are, and then the second thing it will do is we'll take that out. We'll put letter something of something else here. We'll use variable A. instead of world, and then we'll pick some letter here. The only difference is in this case the first letter is letter 1 and not letter 0. So it starts with 1 and not 0 in this case. But let's go ahead and just to see what this program is going to do at this point. It says 5 because there are 5 letters in the variable a. And then it switches to A because the letter A is the first letter of those 5. Are we doing okay so far with this? Do you think we can make Scratch spell out each and every letter of the variable A, given that what we have learned so far? Okay, let's go ahead and see how we can do that. To do that, one of the things we have to do is we have to make a new variable. Okay, because we need a variable to control which letter of the word am I focusing on at this point. I'll just call it I. In this case, what else do we need? Do you think we need some kind of a loop, something that is done repetitively? Okay, because I said for each letter, so most of the time when you hear for each letter or for each blah blah blah, it implies the use of a loop because you're doing it to every blah 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 item inside the collection. So now we go to control and find out, we try to find out which loop do we want to use. Loops are very easy to identify because it is all graphical. When you see this little arrow going back up, that implies it is a loop. Can everybody see this? Because the projector may, well, this is a very, very nice projector. You can actually quite clearly, see the little arrow that goes back up. That implies we have a loop. We probably don't want to use forever because there are only 5 letters in this word, and I only want to do it 5 times. Forever if, I probably don't want to do that either. So that leaves us only with one last choice, which is repeat until. Well, there's one more, I think, somewhere
Further up.
It's up at the top right.
But I don't think I want this either. Repeat 10 times. Because what that will do, this construct here, repeat how many times? It will do something over and over again, but it doesn't update I automatically. Yep.
Could you just use variable A, repeat 5 times?
Repeat A.
Yeah. It'll repeat how many letters are in there.
Repeat length of A, yeah.
But then how do I select that letter and have the sprite to say it?
Set I to length of A. Right.
No, if you set I to length of A, it is a constant 5. Because the length of A is always 5. A always has A, B, C, D, E inside it. So I will still have to maintain I as a counter to count which letter I want to print. So I might as well just use a general purpose loop so that I keep track of when to get out of the loop.
I plus 1.
I starts with 1. Okay, very
I
good.
plus 1 for the
Inside the loop.
inside the loop.
Yeah. Okay, so we'll go ahead and put the loop in. So we'll put repeat until here. And then we'll put this particular say inside it. And then we also have to deal with the variable. So it's no longer letter I, it's no longer letter 1 because we want to use a variable I to control which part of the word I want to print. So I have to go to variables and drag I in place of 1. Is that making any sense so far? Okay. And I also have to make sure I remember how to use repeat until because I have to specify a condition, in this case, an exit condition. When do I get out of the loop?
I equals 5.
Well, maybe I should not use the constant 5 because I might
I
want to
equals A.
change
I equal
length of A.
greater than length of A.
Oh, length of A.
Okay, I has to be less than or equal to, in this case, not greater than the length of A. So we go to operators, and then we choose not first. That's the outer one. And, oh, I take it back because I'm still thinking in while loops. This is a repeat until. So we can say greater than, and then we can say when I is greater than the length of A. Is that making any sense? All right. I'm still missing a few things. For instance, I'm missing the part that updates I in the loop. So I have to say change I by 1 and put it inside the loop after the say. That's increment. That's the same as I gets I plus 1 in our pseudocode language.
They said I to 1.
Hmm?
Don't you
And then we have to set I to 1. And where would be a good place to put that?
Before the loop.
Before the loop. Very good. So we say set I to 1. Like that. Think it will do it? Let's give it a try. And probably we don't want to wait 5 seconds for each letter. 2 seconds.
Yeah.
Okay. And we'll get rid of the say stop. So we'll just toss that away. And
Does it,
yep.
does it save that when you toss it away and back
No.
into the pool? It's
No, it's just removed. It's just deleted.
okay.
Okay. A, B, C, D, E. Okay. Now that is the most basic block that you need when you try to write the game Hangman. Okay, because you need to be able to examine each and every letter, not only of the word that you're guessing, the actual solution, but also you need to maintain which parts of the word is already guessed correctly. Okay, so there are a few things you have to do to make that work, but this is a basic principle to get it done. And this is array. I mean, it really is the concept of an array, only with a few changes. The first one is we set the index to 1 to begin with, because the first letter inside a word, at least in Scratch, has an index of 1 instead of 0. The second thing is, instead of using the bar notation to find out how many items are in the array, we use an operator called length of something. Okay, so that's a notation change. Other than that, and also instead of using the square brackets to indicate which item inside the collection we want to use, we use an operator called letter blah of blah. Those are the only changes, but we still see all the operations that we can do with arrays. Are there any questions at this point about how this program actually relates to what we have talked about regarding arrays? Question?
Okay. Now how are we going to use this in Hangman again? How do we use this in Hangman again?
Ah, that's a good question. How do we use this in the game of Hangman? Now tell me, how do we play the game Hangman? Because we have to play the game a few times to understand the logic of the game Hangman. Go ahead.
There's going to be a negative when they don't get the right letter. It's going to add another piece to the guy.
Well, adding a piece to the guy is the least of our worry. Our main worry is, okay, so here's the game Hangman, all right? And I have to tell you how long the word is first, okay? Because otherwise it's pretty hard to do it. Okay, so let's say, okay, I have a word in my mind already. Okay, go ahead.
A.
Give me a letter.
A.
Okay, you give me a letter A, okay? So what do you think I have to go through in my mind to determine what to do next?
Is there an A in that
You have to
string?
do a comparison.
Is there an A? Okay. Now, when you do it manually, you can just eyeball the whole thing, okay, or mentally eyeball the whole thing, because you can actually see the word in your mind, and then you say, oh, okay, there are this A and this A here. But in a program, you cannot eyeball the whole word all at the same time. So what I have to do, okay, let me tell you what the word is. Okay, the word is break, B-R-E-A-K. Okay. So from your perspective as a human, you can spot right away. It's like, oh, that's an A, we'll just put an A here. But your program doesn't work that way. Your program can only compare one letter at a time. It can only match one letter at a time. So when you say, oh, I want to use letter A and tell me whether there are any letter A or any letters of A in the word, I have to go to the first one and go, is that a letter A? Nope. Is that a letter A? No. Is that a letter A? No. Is that a letter A? Ah, we have a match here. But now the question is, What if it is a letter A? What do?
You're supposed to continue.
Well, you're supposed to continue to find out whether there are additional A's. So let's say this is the only A, so we have a match here. This is not an A. What else do you have to do when you play that game?
Sign it.
Show it.
You have to show it. Okay? So now we have two arrays. We have one array to store the actual word that the computer is hiding from you that you're guessing. And then we have another array to represent how much of that word is already guessed. Are we doing okay so far with this?
We also need another array to maintain what letters have been guessed.
Exactly. Okay? Because now if the person says, okay, let's say this is not a very sane person and try this, okay? X. Okay? That's not an X. That's not an X. That's not an X. I don't even want to match this one because this letter has been matched already. This is not letter X, then what do? There's no match here.
You
Draw.
draw ahead.
I have to remember there's no match. Okay? So I have to advance this to the next, picture, next frame. Let's say the person says, okay, I'll try another unlikely letter, Z. Okay, I have to advance this to the next stage too. This is easy. This is pretty easy to do because you can keep track of multiple sprites. All you have to do is to say change costume to the next available one. That's easy to do. What if the person says, how about B? Well, we have one match. Okay, so we match B to B. Change this to a B, move on to this one. R is not a B, E is not a B. This has matched already. You can keep matching it again, but that's okay. It doesn't really matter. And this is K again. Okay, let's say this person keep guessing all the unlikely letters. Q. Give me one that is unlikely.
Y.
Y. Y is actually pretty likely, and
J.
a lot of words. J. J is a good one. All the high value ones in scribbles. Q. I got Q already.
P.
Hmm?
P.
P. Lots of words start with P.
Yeah.
Okay, so anyway, so let's say that person has guessed it, and the little person is almost done. Okay, just missing a leg now. Okay, now if you don't write this program correctly, that person can keep guessing A, because guess what? A matches, A matches, A matches. So this guy won't die. Okay, so what you need to do is to say, oh, guess what? A, we have used A already. It doesn't count. Yep.
Use like a if-then statement, like if the whatever the user guesses is in that string, then then increase the variable or not apply part something.
Well, the first thing you have to do is to maintain this as an array. It's an array of the letters that have been used already. So that array gets bigger and bigger and bigger because the more guesses that person has made, then the more letters you have in that array. So your very first task is to take the letter that the person is guessing and look up this table and say, do we have a match here? Because if there is a match, go back and ask for another letter. That's the first thing you have to do. If the letter is not found in the previously used table, then you can proceed to this portion. But when you proceed to this portion, there are also two arrays because you have one array to maintain the portions of the word that have been guessed correctly already, and another one to maintain the actual word that you're guessing. So the program is actually quite complex. It's not as simple as it seems. And what we have here, this logic that we have in Scratch at this point, is only doing the very first part. Give me an array with all the letters that have been guessed already, and I can tell you whether it is in there or not. Now, this program doesn't even do that because all it does is to say, all it does is to show you the letter that is in the word. It doesn't even do a comparison. Okay, so can you guys, kind of have a general idea of, why I said, the mastermind game? I mean, it's not the mastermind. That's another really fun game to program, but even more complex than this one. Why Hangman is actually, not as simple as it seems. Okay, very simple things that we can do. Sometimes it's not that easy to encode and write a program so that your computer can do the same thing. Are we doing okay so far? Okay. Let's make this game a little bit closer to the hangman game. Okay. In other words, now this is actually how I write my programs. I don't start, if I want to write the game, hangman, I don't just, mentally go through the whole process, have everything figured out, and then just type the program from line 1 all the way down to line 265. Yep.
It's possible to make the game Snake on here, right?
Snake?
Uh-huh. Like
How do you play?
Dots randomly pop up, and if
Oh, you have to
following the
avoid.
arrow, following the arrow,
Yeah, you can.
collect the
Yep.
dots to make the snake longer.
You can collect the dots. You can also avoid the dots too. You can have I think it's easy to
Or
write
it's like-
the game Tron. I mean Tron is easy because you have two colors, and basically you have to use sense when the sprite collides with a certain color, and that's a collision. And if that color is not your own color, can you collide with your own color? You cannot, right? So you have a background color, and any type of other colors is considered a bad collision. So Tron is actually pretty easy to write because you can intercept the keys too. If you look under sense, I think you can actually let's see.
Key pressed.
Hmm?
So basically, all the
Key
super
press,
games
yep.
that came out the first time computer came out, you could write it, right?
Write it in the scratch.
Yeah.
Yep.
All the Atari games.
All right. Well, let's go on and move from here, and then go. Okay, if I give you a letter, okay, can we tell whether that letter is in that word or not? Okay. Now, before we go any further, it's kind of cumbersome to use an assignment statement to hard code the content of A. So we'll make that go away, and instead we'll use sensing, and we'll have the sprite to ask us about that word. Okay, so we'll say ask, give me a word, and wait. So what that will do is it will stop the program's execution, prompt, and say, okay, end user type something, and then press the enter key or click OK. Well, let's go ahead and start this program and see what happens. That's all it does. Give me a word is what I use here as a prompt, and it's just giving me a prompt here until I type something and click the check mark. It's not going to proceed.
Where's it gonna go?
It's not going anywhere. That's the thing. That's a very good question, because where is it going? I mean, it's asking me a question. I can give it an answer, but where does the answer go? Well, it doesn't go anywhere until you specify this. So now I can say set A to, but not 0. I go back to sensing, answer. It's the answer to the previous ask. Okay, so that's a pretty neat way of combining, prompting a question and also be able to utilize the answer to that question. All right, so this program is a little bit more interesting now because it's not just hard-coded to A, B, C, D, E. You can give it a really long word and it will take a long time to go through all those letters. But let's give it a try, and just say, tag T, A, K. So the program does what it's supposed to. Very good, okay? Now we have to make it even a little better. Let's go ahead and make another new variable. We'll use C for character. And now we want to find out, is that character in the array? Okay, the very, very first step that you have to do when you play the mastermind game. Okay. Before we do anything else, we have to ask again and set one of the variables, variable C in this case, to that letter. So we go back to sensing, and then we ask, give me a letter, and then we use variable, set variable C to answer. Now, right here, I'm making a very bold assumption that the end user won't try to trick me and give me multiple characters as a single letter. Yep.
So
the using answer twice is just it's the answer proceeding after the question. Like
Yes, it's the answer to the previous question.
okay.
All right. So now that I know what character C is, I can actually do the comparison. I have to do the comparison inside the loop because I have to do it. I have to do the compare for each letter in the word itself. What do I do when I find there's a match?
Say ta-da.
Well, let's just say that we'll say ta-da. Okay, so that's fine. But what type of control do we need here? Because we don't want to say ta-da when there's no match. We only want to say ta-da when
If.
the aha, and that's a conditional statement. Very good. See, you have to give yourself, you have to ask yourself, these questions in order to determine what type of statement am I looking for. So in this case, I'm looking for a conditional statement or if statement. And I'll just use the simple if for now. We can use something more complicated later. Now this one has to go out of the conditional statement because I have to increment for each iteration anyway. This is why GUI programming is not all that desirable because just changing the program a little bit takes a lot of effort. Okay, there's a lot of dragging and dropping. So what should I say here? What I want to do is the program to give me a ta-da, when there's a match for a letter. So what should I put into the conditional part of the conditional statement?
If C.
Okay, go ahead. Well, see, this is the other thing about graphical programming. I cannot just type, oh, I know it has to do with C, so I would say if space C, and then I think about what operator goes next, because I have to think about the operator first. So what operator am I looking for here? Equality, right? I want to see if they are the same or different. If you can check one or the other because they're flip sides of each other. So we'll go to operators again, and then we take a look at the operators that we have and find out which one is the easiest one to use. In this case, equality is the easiest one to use, but I'm not looking for equality. I'm looking for different because I want to say ta-da we do want equality because when it matches, we want to say ta-da. Okay, so we put the equality check here, and what am I comparing to what else?
C to the answer.
We are checking. We're comparing C to no.
No, letter
I of A. Basically, that's our A bracket I using our array terminology. So we'll just drag this and stash it over there. And instead of saying hello for 2 seconds, as you said, we'll just say ta-da. Ta-da. Okay? So every time when there's a match, it will say ta-da.
It's only going to run through this program once, though. It'll check the letters, and then that'll be it.
Correct.
We want to continue to ask questions and feed it.
Well, we'll put another loop in later on. But this is how I write my program. I write programs, guess what? From the inside out. Okay? Now, when you write your program inside out, what is the benefit of writing a program from the inside out instead of writing it from the outside in and just, oh, I know exactly what the entire program is supposed to do. I'll start from line 1. How do you test that program?
You have, in each little block, you can test, see if that block works before you put it into a bigger thing.
Exactly.
Framework.
Exactly. That's exactly why I'm writing this program from the inside out. I start with the most primitive and the easiest operations. I test run the program. Oh, okay, that does what I think it should do. Then I move on. I build on top of that. I make the program a little bit bigger. I test it again to make sure the program does what it's supposed to do. Then I move on. If it does not do what it's supposed to do, I stop and I debug the program right away. If I only introduce 3 or 4 lines each time before I test it again, then the worst I can do is to debug 3 or 4 lines. Okay? Does it make sense for me to write, like 20 or 40 lines of code, and then I go back and say, well, I better test this? Okay? Now, some people can do that. Okay? As you gain experience, sometimes, especially with mundane logic, you probably can write 20 or 40 lines of code and then test it again. But it does not make any sense to anyone of any skill level to write hundreds of lines of code before testing something. Okay? As obvious as it seems, people will do that. When you have hundreds of new lines of code, there's no way to tell which line is causing the program to bomb out. Okay? Well, you can, but it's very, very hard to do. So this is another thing I want to illustrate is how do you write a program step by step. Don't try to write the entire program all at once. Write it a little bit, add a little more code, test the program, add more code to it, test again, and so on. This is a luxury that you guys can afford, but earlier programmers cannot. Why do you think I said that?
All they do is debugging.
Sorry?
Because they do debugging from other people's programs.
Not that. It was a physical limitation. Now, back in the good old days, do you think we'll have a computer in every classroom? No. Okay. So what happened in the good old days?
You have to have the complete program.
Yeah, you have to write the whole program and take it somewhere to get it tested.
Well, first of all, how is your program stored? Oh, I got my thumb drive, my little SD card.
On a floppy disk or even a cardboard
Punch card.
Punch cards. Okay. Now, many of you are probably completely foreign to the concept of punch cards. Okay. A punch card, as the name implies, is a card, as in a paper card, not a credit card kind of card. It's a paper card. So imagine this. Okay, you have basically cards. Each one is basically paper based, and it has rows and columns. If I remember correctly, the columns represent letters, and the rows represent the position on the line, or the other way around. Okay? In other words, a single hole represents one letter in your program. I cannot remember whether the rows, represent lines, or whether whether the columns represent lines, or whether the rows represent lines. But one piece of paper represents one line in your program.
Oh, that's horrible.
Okay? Now, how do you represent an entire program when one sheet, one little card, is one line? What happens when you have a 500-line program? You have 500 cards. Yep.
Keep them in order.
So you could accidentally just shuffle them or all that was
Yes, in the early days, if you shuffle the order out of order, then your program won't work because the letters will be out of order. Later on, they got smart, and they actually have the punch holes. They have little holes on each card to indicate its order within a stack. So you can actually put it into an auto sorter to automatically sort a deck of cards that's out of order. Okay, so they have minor improvements over the time. Okay, so now you wrote your program. You have your stack of cards, and then what do you do with a stack of cards? You run to the data center, okay, because you don't have a computer that you can run your program, not in your office, not in the building, okay. You have to probably take it across the street, to a mainframe, processing center, data processing center, and then you hand the stack of cards carefully over the counter to someone. That person will say, okay, your job will run, guess what, sometime tonight. Okay? And come back tomorrow in the afternoon and we'll give you the results of your program. So you give the stack of cards, you go back to your office. I have no idea what you're going to do after that. Okay? Start a new stack. So the next day in the afternoon, you went back to the data center and they'll give you a printout. This is the output of your program. And your program will probably say something like, oh, error, blah, 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 the program crashed. Then what do? Back to the drawing board. Try to figure out what's wrong with your program. Once you figure out what's wrong with your program, then you make a new stack of cards. You walk over to the data center again, and then you can test run the program again. The next day you can collect your results. Nothing quite like what we just did. And that's why I said you guys are lucky. You have the luxury to change quickly very quickly change your program and then run it again and test your program. Okay? Now, what does that do to the early programmers? Make them
mad.
insane. Yes, yes, that's definitely one of the things. But they also make them better programmers, because you don't have the luxury to guess and oh, I just throw a dart to see if that's the problem. You actually have to go through your mind and go through the program very, very analytically to figure out why my program did not work. You are forced to write programs in a way where you cannot introduce bugs easily. When you do introduce bugs, you have to make sure your program will catch those bugs easily too. All right, so getting back to the current time. All right, so let's see whether this program does it or not. We'll go ahead and run the program. It will ask me for a word first. We'll just put in TAK, and then it will ask me for a letter. I'm not going to trick the program. I'm just going to put in A, which is in TAK, so it says tada. Okay. Now, instead of using tada, we want to make it say it has a match with which letter. Okay, maybe we want to do something like that. So how do we do that? Yep.
This is also case sensitive, too.
It is actually case insensitive.
It is?
If I remember correctly, the Scratch is insensitive, so I can use tag and then use the lowercase t. I think it was to make a match. Yep.
Okay.
So the match is case insensitive. Now, if I don't want it to say ta-da, instead I want it to say letter blah matches, how do I do that? It seems pretty easy, right? All I want is Scratch to say letter 2 matches. So this part depends on I. This is static. That's also static. It seems easy enough, but nothing is easy when it is supposed to be. Okay. Let's start with some experimentation. Okay. So let's start with this. Letter I matches. Because that seems like what we want to do, right? And we run the program. Tag, and we look for letter A, so it should say 2, right? Letter 2 matches. And it says letter I matches. Well, that's because if it is inside the white portion here, that's called literal. In other words, whatever you type there will be printed exactly the same way you specify it. If I say letter I, it will say letter I. It does not understand that I refers to variable I, or the value of variable I. Yep.
That's what I was going to say. Say you get one of those little things that goes in there, value, or...
We need to use an operator that we have not used yet. It's called a join operator. Now, the join operator is also called concatenation. In other words, it takes one thing, it takes another thing, it makes a new thing that is the combination of the two. Now, one thing that's really good about Scratch is you can just test the operator without doing anything else. So you can just click it. Okay, so hello and world, when you concatenate, it becomes hello world. Okay, so that can be handy. Maybe we should use something like that. So I'll stash it here, and I won't try to do anything that's too fancy yet. I'll just say letter. Instead of world, I will use the variable I, because after all, I want to use the value of variable I to display. Okay, are we doing okay so far? So let's see how we're doing here. Once again, tag and letter A. It says letter 2. Not quite exactly what I want, but closer. Okay, we just solved a problem that is really hard, which is how do we display the value of a variable when we print something, and we just did that. The space is easy to take care of. If you want that space between letter and the number, just put a space at the very end here, and it will print that space. That's not an issue. But what about matches at the very end?
We need another join.
We need another join. Very good. So now we have an option. We can put the outer join, on the outside. We can also put the join, in the inside. You can do it either way. It will still work. So we'll do the outside one. Okay, so we'll do, because it's easier to do. Oh, yeah. There we go. No.
No, just put it back in.
I just stash this back into here, and then change this one to matches. All right. All right. So if you, I'm not sure. You guys can see the indentation here. There's a little indentation. So you can see there's a join operation here, which gives us one thing. There's the literal string matches, which gives us the second thing, and the outer join is joining those two together. If you want to represent this using a more graphical way, I know it's kind of funny because this is already pretty graphical. We have a join. This is the outer join. The outer join can only join two things. The one thing that it wants to join is the result of another join. The other thing is just saying matches with a space at the beginning. The inner join can only join two things too. The first thing is the literal letters, letter with a space at the end, and then the second thing is the value of variable I. So this is another way to look at that kind of complicated, cumbersome thing. Is if there are two joins, we have to perform this one first. It gives us something for the outer join to join with matches. Are we doing okay so far with this? Okay, so it's time to test the program. See, I did not even add any new lines this time. I just changed something in the program, and I did not take it for granted. I did not say, oh, this has to work, I can just move on to something else. I tested first. Okay, give me a word. Okay. Okay, this time I'll give it, I don't know what that means, it just sounds cool in Japanese. Hope it's not a swear word in Japanese. All right. You found 2, 4, and 6. Is that right? Letter 2, letter 4, and letter 6. All right. So we have, the very basic building blocks for the game, okay, for the hangman game. Because now we have a mechanism to what? Match one single letter to a word. That's one portion. That's maybe 1/3 of the hangman game. But you can also see the process. Okay, it's not about the end product. I mean, the end product at this point is there, and it illustrates how to use arrays and indexing and all that stuff. But it's the process that I think is the most important part. This class is problem solving and algorithm design. Problem solving and algorithm design, unfortunately, is not something that can easily be taught. I can teach you syntax. That's easy because those are rules. I can teach you the semantics of the bar operator because that's by definition. It gives you the number of items in the array. I can teach you the concept of array indexing. That's easy because it's just an operation that your computer can perform. But how to write a program is really hard to teach. Okay? And this is an illustration of how to write a program. You don't start from line 1 and keep typing. You start from the inside out so that you can test your program with smaller steps and always give it the same test case, all the time. Now, I'm not really done testing this program because there are cases that I have not tested yet. In other words, I can give it tag here and look for a letter that is not in the word because it's not supposed to print anything. So we'll give it, Z, and the program did not do anything. It did not print anything because it's not supposed to. So when you test a program, you have to test it with different test cases to make sure that it works in as many cases as you can think of. Yep.
If else would be the next step. So it would say like you're wrong or doesn't.
You can do that, but sometimes you're not interested in when there's no match. The next thing you want to do, especially when you're trying to implement the hangman game, is after the loop, how can you tell whether there was a match or not? when you went through the loop. Yep.
Print it.
Hmm?
Print the letter into the
But
file.
printing is not going to do any good because your own program inside the script here cannot see what you have printed. So how do I keep track of, oh yeah, we had 3 matches from that loop.
Save the match.
You can save the number of matches. Okay? Every time you have a match, in addition to saying or in place of saying something, you can increment a counter. And you reset the counter before the loop. So that way, if the counter is 0, that means you have not made any match when you went through the loop. When the counter is more than 0, then you know that you have at least 1 match. Okay, so you have to add all these things to your program one by one. So let's do that step 2. So we have to make another variable for this purpose. I'll call it m for matches. And what you have to do is to reset the value of m before the loop. You have to reset it to 0 because we want to say, okay, the assumption is there's no match unless I can see that there's a match. So inside here, we can say change m by 1, but you have to make sure change m by 1 is inside the conditional statement, not just inside the loop, but it also has to be inside the conditional statement. And then, at this point, outside of the loop, I can finally make a statement of whether there has been a match or not. Because now I can use a conditional statement. And I can use a if then else in this case if I want to print something in both cases. And then go to operator. I can use greater than 0. So I can say if m is greater than 0. And I go to say the man lives. Hangman days. And else, what does the else correspond to? The else corresponds to, and there's no match because if the then is corresponding to m is greater than 0, the else is corresponding to m is not greater than 0. But since I initialized m to 0, and the only thing I can do to it is to increment it, the else really corresponds to m equals to 0 because it cannot be less than 0, at least not in this program. Okay? So we'll just say 1 more nail. Okay? All right, so we'll go ahead and run this program, and I don't need this part anymore. Okay, let's close. I can get rid of not the whole thing. This is why graphical programming is problematic because just editing the program for simple stuff, removing a single line, is a chore. There we go. Now we'll run the program again. Yep.
Could you run the program and just leave that down there to put it back in later?
Yeah, you can. Yeah, you can just stash it somewhere. If you leave some code kind of just hanging around,
yeah,
then there's no way to trigger the execution of that, which is fine because it's just some code somewhere in your program. If you need it back, you can always drag it back into the actual program. So yes, you can keep it there if you want to. But in my case, I don't really need to keep track of that anymore because that's really for debugging purposes. So I'll just go ahead and give it, say tag again, and give it the letter A to find, and it says the man lives. Okay. And if you go to Burning Man, then it will say the man burns. Are we doing okay so far with this program so far? At this point, is the logic okay? Because we really have not introduced any new concepts dealing with this. Maybe join. Okay, join is kind of the new concept, but we only need to use join for the purpose of printing something. Now, when you actually play the game Hangman, you will need join not only for printing something, but also to keep track of which letter have been guessed already. Is that what you did? No? You did it some...
I did it very differently.
Very differently. Okay.
Look at it.
Okay. Are there any other questions? Any questions about the approach to solve a problem using an algorithm? Because that, to me, is more important than the syntax of anything. No questions?
Is there a way to, this is kind of like just in arrays in general, is there like an easy way to reference time? Like if
Reference time.
if this happens, start time now, you know?
Yes, most programming languages will allow you to access the current time in one way or another. So most of the time in Unix systems, you can get the time in an epoch format, which is the number of seconds since 1970, January 1st, midnight. So that's going to be a huge number in number of seconds. But it's also a nice thing because you can now easily compare two times. If I give you a timestamp, give you another timestamp, they're just integers. A simple greater than or less than will do the comparison. On the other hand, if you keep track of time like humans do, year, month, and day, it's a lot harder to actually do the comparison.
It's a mod 12.
No, it's actually much more difficult than that. You have to compare the year first. If the year already gives you the ordering, then you're fine. But if the years are the same, then you have to compare the months. If the months are the same, then you have to compare the days. If the days are the same, you have to compare the hours and so on.
Okay.
So the comparison logic of the human format of time is actually more complicated than the machine understanding of time, which is really just the number of seconds or the number of milliseconds since a particular time.
Okay.
Yep. All right. Well, so let's go ahead and see if we can do something like this, but in our pseudocode and trace that using a spreadsheet. Yep.
I am kind of confused on how to test it, like block by block.
Okay.
In the program, everything's supposed to be related. So how would that work? Test this without one thing, how would it work?
So you're talking about how to test a program when the dependent block is not available yet. That means you have to implement the dependent block first. In other words, you have to start with the portion of the program that depends on nothing else. Okay, that's your foundation. There's nothing underneath the foundation, so you have to start with the foundation first. And once you have the lowest level of foundation done, then you can build on top of that. And then you can build on top of that, and so on. It's a little bit harder when we don't have subroutines. So by the time we talk about subroutines, then we'll have a very useful mechanism to do what you just suggested. Is basically how do we start with that and then have building blocks to build upon that. Now subroutines are really cool because it makes it possible to share code. You can specify the code once, and then you can say, oh, I want to use that here, 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 and here. You can refer to that code, the same block of code, from multiple places in your program. But we are not quite there yet. All right, so we'll go ahead and save this file. In fact, I'll save it to today's folder. So if you have Scratch installed, you can actually pop this up and make your own modification and turn in your Hangman implementation in the next class. I'm pretty sure some of you can do that already. So we'll go to user, today's folder, and give it a name. I'll call this partial Hangman. I think it would be fun to make it a Burning Man, so it will start with the foot, and then the flame would get up to the knees, and Yep, go ahead.
Can you make your own sprite? Is that what you're basically going to have to do to make a Hangman?
Yeah, absolutely. You just go to costumes, and then you can either use import, and if you have pictures that you have drawn already or photographs that you want to use, you can just import it. If not, you can use Paint and start from scratch.
So costume 1 would be the gallows and everything.
Sorry?
Costume 1 would be the gallows.
Gallows. Oh, you mean that can be the background?
Oh, that's
That can be the background entirely.
right.
Yeah, so it's up to you. I mean, there are many ways to do it, but I would suggest that you draw the whole thing first, and then you delete. Use the deletion process to get it down to the original, the first,
Right.
just the head.
How do you want us to turn it into?
Well, at this point, it's just a brain teaser, so there's nothing to turn in.
Because I just uploaded it to Scratch.
Right, that's fine. You know, you gave me the link to it too, so I can definitely play with it over there. So if you want a Burning Man instead of a hangman, you can use flames. Yeah, you can start with that, and then make the flame bigger and bigger until the whole man is consumed.
I think you need therapy.
Play some.
Uh,
Could have a play some techno music at the end. Play some
Burning Man,
techno
yeah.
music at the end.
Can you add sound effects like that?
Yes, you can.
Yeah.
Yep, absolutely. It already comes with some sounds. So if you look into sounds, it has the meow sound, but you can also import. And there are so many sounds already. I think there's a screaming somewhere. Yep, got scream, female. Turn on speaker. And you can get to the male version too. And the alternate version.
It's a good one.
But you can see how fun it is to use Scratch. I mean, it really is a lot of fun. I mean, that's the intent of Scratch, is not to introduce yet another academic beginning programming language. Is to make it fun. It makes it. This is the stage. It's called the stage for a reason, because this is where the players actually participate. The sprites are players. You are writing the scripts for the players. How are they supposed to do, what are they supposed to do, and how are they supposed to interact with each other? Each one can do independent things. So that's the whole idea of Scratch, is to make it so fun, with multimedia and stuff like that, so that when you're learning programming, you don't even realize that you're learning programming. Unlike this class. I make it very clear that you're learning programming in this class. Otherwise, they will say I'm not doing my job. All right, are you guys okay with this? Okay. I'm just, puzzled, why someone wants to open the door and close it. Were they just peeking inside? I mean,
It's like playing
They're like playing with a lock or something.
Yeah, it's like corn block or something.
Yeah, it seems like a jiggle in the handle
Uh-huh.
for some reason.
Hmm.
They love music.
All right, so we'll save this. So now back to the boring stuff. Has anyone noticed the unusual ratio between male and female when it comes to programming classes?
I can see
No,
that
it's perfectly normal. I mean, this is fine.
the relationship has to do with most computer-related fields.
Yes. So, well, I know this is not completely related to what I'm talking about, but but I want to share this. I really want to. And I cannot remember. Okay, let's see. Google Vice President. I can't remember her name. Oops, none of these. Nope. Oh, that's, what is her name? Marissa Maya.
I think it was the first result.
Yeah.
Was
Best guess where
Yeah.
Google Vice President is.
That's interesting. Of all the vice presidents, now where do I click it then? Just any of these links?
Show sources.
All right. Also, let me show you, the first time, I, noticed, her existence. Okay. Lady. Gaga. That was it. I mean, it was one of the interviews. Google goes gaga.
Hi, I'm Marissa Meyer, and I'm really excited today to be joined by the world famous, incredibly talented, the one and only Lady Gaga.
But I want a scene where okay, right there. This is a good one. Okay, can anyone tell who's the geek and who's the freak? Okay. Well, I mean, I like Lady Gaga too, but she does look a little freaky sometimes. And she looks, not just normal, but a little bit geeky. And at first I thought, they just went through the whole Google organization, because they have to host an event. This is actually hosted at Google, and find someone who is at least presentable in front of a camera, and that's how they picked her. Maybe she's just a secretary or something. Okay, I did not realize she's actually the vice president at Google. She's one of the first 20 employees of Google. Okay, with a master's degree in computer science from Stanford, and her research topic was artificial intelligence. Now, AI in any other school, I would just call that, yeah, well, that's kind of fuzzy stuff, okay? Because I did my own research in AI, so I know that stuff. It's all kind of fuzzy stuff. You can argue your way out of most things. But at Stanford, it's not the same. Stanford is one of the top 3 schools nationwide for computer science in general, and also particularly in artificial intelligence and robotics. So this is not just someone working for Google. She's actually pretty talented. She has to be talented to stay that long at Google. Okay, so if you know anyone like a niece or daughter or girlfriend or whatever who is looking into getting into the computer science field, but kind of feel that, well, I don't know, they don't seem to have any really good role model, I think she might make a good role model. As a female, a software engineer working in the field. But why do you think there's such a strange proportion when it comes to computer science or engineering and stuff like that? I blame it on Barbie. Well, Barbie is only a reflection of society as a whole, but it is a very iconic kind of figure. I'm not sure whether this is real or not, but I remember in one of the episodes of The Simpsons. Yeah, go ahead.
I was just going to say, could you make the same correlation that as musicians, you see a far finite group of women that are musicians as well as it is in the computer industry?
I do not know. I mean, I'm not that much into the entertainment industry, so I cannot really tell whether there's a big discrepancy also.
The reason I say that is because I heard and read somewhere that interchangeably programmers, people that are very good at their job programming, make good musicians and vice versa. And it has something to do with the synapses in the brain and how they have to think and analyze.
Yeah, because music is patterns. Regardless of the genre, music is pattern. That includes rap. Includes hip hop, classical. It goes all the way back to Johann Sebastian Bach. You look at his 2-part inventions. It's all math. You can call it the music part is like an afterthought, but the thing is so well structured. It is more math than it is music.
What is that called?
Bach.
Bach.
J.S. Bach.
Well, what is his invention or whatever?
He wrote a lot of 2-part inventions, mostly intended for either organs or harpsichords. Not even pianos, because it was not invented yet.
Oh, really?
Yep. Piano is actually just a part of the name of the instrument. The full name is piano forte, which means it can change the intensity of the sound.
So, loud and very quiet.
Yeah, piano is soft and forte is loud. Before that, they have harpsichords where the volume cannot change. You cannot play one note loud and play the next soft. The whole thing can be soft, the whole thing can be loud, but you cannot adjust it in between. Okay, digressions. Now, but this seems like a very very far-fetched digression from the core of this class. But I can tell you it is not. There is a reason why Google invited Lady Gaga for this interview over there. Why do you think they invited Lady Gaga instead of like a political candidate or something like that?
She's a role model. Could be viewed as a role model, so maybe by young girls, and to by comparison have the counter of her act. I don't know.
Well, to the organization, to Google as an organization, what is this buying Google? I mean, Google would not do anything. Well, sometimes they do, but most of the time they do something for a reason, for the company, for the corporation, and for direction they're heading.
To get more viewers.
To get more viewers? Okay, well, they're getting more viewers, but this is, it's not going to be changed. It's not changing that all that much. But it signifies a direction that Google is heading, that Amazon is heading as well, that Apple is heading as well, and it's something that we have talked about already. The cloud. Okay? So what does Lady Gaga has to do with the cloud? Music. Okay, very good.
She's famous. There's a large amount of people that follow her lead, and as advertising,
it's good advertising. She's a good representation of the entertainment industry.
And thus her popularity to get people into this cloud concept.
Okay, but where's the connection?
I could be wrong, but a lot of pop stars like to have their own apps so that you can easily just, like this YouTube video, you can click on the little chiclet button and see any particular video concert that she has done, or in this case, an interview. So you don't have to search very far if you're dialed into
Correct.
their site.
That's exactly what it is. Google is setting itself up for media distribution. Okay? And same with Apple. Apple has been doing it for a while with iTunes. So what is in media distribution? Why are all these giants, Microsoft, Google, Apple, Amazon, why are these four super big companies moving in that direction? Advertising, yep.
I think they're trying to get like a unified. It's almost as if Google wants to anything and everything you'd ever need on the internet, you can get from Google. They want like this unified package where you need music, movies, email, whatever you need. It's all packaged in Google.
Okay, go ahead.
Distribution is dirt cheap and makes a ton of money.
It makes tons of money. That's exactly it.
I was really on the same level, saying that with Netflix, Hulu, and all those other media-driven type sites, this is in the same direction of a giant like Google were to get hold of this multimedia type of thing. You could just
Exactly.
click it on.
Where did you get your entertainment 20 years ago? Radio, television. You buy CDs from stores. You buy DVD from stores. You rent DVDs from Blockbuster down the street.
20 years ago, not DVDs.
Oh, okay, fine. VCDs, okay, those huge, video discs, right? I mean, you can, kill someone with that. Yeah, but where are those things now? Where's Blockbuster? Busting. Okay, so where do you guys get your entertainment now? Netflix. YouTube. Okay. Okay, let me ask you another question. What if the internet is down? You're stuck, right?
Read a book.
Yes.
There was a joke. What is a computer without the internet? It's a big MP3 player. What was that? Computer without the internet is a big MP3 player.
It's a big MP3 player, and guess what? Very soon it's going to be an MP3 player with nothing to play. Okay, I was just ordering, some music tracks for a family friend the other day, and this is done through Amazon, and the first recommended option is to quote unquote download that music to your cloud storage. Okay, the first option is not to download to your computer, but to download it to the cloud storage. Okay, that's where everything is heading. Now, when you have control over that sort of thing, why would that be, a source of revenue?
Cloud, they're gonna charge rent to use it, that's what they're getting at. That you have to have a monthly fee.
The monthly fee is the least of their income. They don't generate income from that. It's just like with newspaper. Okay, how many people subscribe to newspaper, like paper-based newspaper? Okay, some people still do. Do you pay subscription fee?
Yeah.
And do you know how much of the actual revenue of the newspaper come from subscription fees?
Very little.
That much. So where's the rest?
Advertising.
Advertising, exactly. And why is Google so big? Advertisement. Okay? Now, how does that relate to you guys? I mean, well, their cloud and all this stuff is fun and interesting and it may be important, but how does it relate to you when you're studying programming at this point? What are you going to program?
Doesn't really matter what you program as long as you can get advertisement. Really, to fund what you really care about and work
right,
on.
right. But the type of programming you'll be doing is going to be where? It's going to be in the cloud. Okay. Now, what does that have to do with programming? I mean, why is that different from programming on your regular desktop computer?
Depending on the type of programming you do, like for instance, if you're describing games, they have to expect certain things, like they have to expect a particular type of video card, or they have to make modifications based on a way a piece of hardware works versus another one. But when you're in the cloud, the only thing that you have to worry about is displaying your content to the user, which is the browser, and it's very small surface when you talk about what you have to expect.
Well, there's a separation now. Before, when you write programs, the entire program is going to run here. Okay, you can unplug your internet connection, and your program will still run fine. Okay, maybe lacking the online gaming part, but for the most part, the single player mode, will still work. With cloud computing, you unplug it, nothing works. Okay? So that means the programming is now separated into two parts. One part is running on your handheld device, could be your cell phone, could be your tablet, could be your PC. The other part is running in the cloud. So that changes programming quite a bit, because now you're writing basically programs in two ways. You're writing a client-server type of program. Yep.
So basically, if you're trying to type an essay, you have to have internet connection.
If you use Google Docs, then you need to have internet connection to type. But you know what? Internet connection is also improving its reliability too. So maybe at some point we can say it's a basic commodity. Internet connection is just like electricity or even running water. Yep.
Don't they have like a sort of an offline mode where they cache a bunch of information?
Some stuff have an offline mode, but I think that will be unnecessary, very soon, because I think, with 3G, 4G, I think all of those will become more and more reliable. So if you cannot get into your 4G, maybe you can get onto Wi-Fi somewhere. So you can always rely on the network actually to get somewhere on the internet.
Is the cloud server or cloud computing only produced or distributed by Apple, or is it by other distributions?
Cloud computing is a terminology to basically just mean that your program is running on a computer, but you have no idea exactly which computer is running your program. So it can be huge. It can be Google, where you have a server farm. I mean, there's a reason why Google is now certified as a energy provider. Okay, they can actually generate its own energy and distribute energy. Okay, because their data center is consuming so much energy, it actually makes sense to become its own provider of energy. So it can be something that huge. But you can also run your own little box at home under your desk. Okay, as long as your program is running there and not here, it is quote unquote in the cloud. Okay, so cloud computing is a very general and vague term to mean that the surface is sitting somewhere on the quote unquote other side of the internet. Okay, and the programming of that, not the basic parts, but when you get into the more in-depth programming, all of that stuff will change. Okay, the database becomes suddenly much more important than it has ever been, for standalone computing. So we'll touch on these topics later, but I just want to kind of point out to you, where things are heading, just so that okay, you need to pay attention to that sort of thing.